Hello, my name is Zach Barbosa. In this presentation, I would like to introduce the UFC Smart Grappling Dummy created by myself, Kyle Beaudry, Trevor Bukovi, and John Rayrao. The electrical side of this project will be encompassed by me and John. This is an interdisciplinary project across electrical, computer, and mechanical engineering. In today's society, a lot of money is circulated around professional sports. To make sports as entertaining as possible, the athletes and their trainers are willing to invest millions of dollars into technology that allows the athletes to train for their matches. It is not only a matter of working out, but becoming used to the conditions of a real match. When practice partners are not available, technology is advanced to the point of simulating the experience of practicing with another person. In the case of combat athletes, they are able to simulate real match conditions by practicing on dummies, performing a variety of techniques such as chokes, strikes, and arm bars. Here is a picture of a typical grappling dummy and how fighters use them. They cost about $500. Of course, the current iteration of grappling dummies that is widely used is not a perfect representation of the human body. Furthermore, it cannot provide the same kind of feedback a normal opponent would as to whether or not someone is using enough force in their techniques or applying force to the correct areas. This provides the context for this project created in collaboration with the UFC, a grappling dummy that provides sensor readings to the force applied to it in order for the user to monitor their performance over time. With the help of mechanical engineers, we were able to create a skeleton that can house the necessary hardware for this task. The UFC Smart Grappling Dummy is able to measure the torque applied when performing an armbar and the pressure in a choke and display this information to the user via an app and Bluetooth. For this, technique is important as the sensors are placed at the ideal points to effectively perform a rear naked choke or armbar. Load cells, which contain strain gauges, are placed in these areas. The strain gauge is configured in a Wheatstone bridge to provide a voltage reading that is proportional to the tension and compression experienced by the load cell. This voltage reading is amplified, processed, and sent by a programmed microcontroller to an app. The converted data is transmitted by EM waves with bandwidths in the Bluetooth range to a smart device. Through the mobile app, the user can see how they have improved over time, and as well as the difference in performance under various levels of exhaustion. The data is visualized in real time through graphs, number displays, and various UI elements. The microcontroller is charged by a portable power bank so that it doesn't need to be connected to a power outlet during use. The power bank can be plugged into a USB charger and will power the device for a considerable amount of time. Currently, we have two sensors that can be connected to the microcontroller. They are placed in the neck and elbow areas. Internally, wires will connect to the microcontroller for transmitting data to the smart device. Here is a demo of the project. So we have a weight on here, and when I take it off, like zoom out. Now you see that it's off. Now when I put it on the arm or on the neck for the choke to simulate chokes, the monitor is off. And now we see that it's moving up. It's supposed to be plateauing up at 5 kilograms. This one's already calibrated. Just applying some force onto it will make the armbar reading go up. And let's put some force on this neck. See how strong I am. Oh, look how much damage I did. Okay. The skeleton shown in this video will be placed inside of a typical grappling dummy that is used by the UFC after removing some of the rags used for stuffing and using the leftovers for padding of the equipment. That concludes our presentation. We would like to thank Dr. Greg, John Mercer, and Duncan French for their help. Thank you for watching.